Hello, Woodstock students. This is Mr. Brennan, and we are going to take a look at some of the multiple choice questions, some selected questions that I thought were of interest and might be helpful in terms of prepping for the exam. We're going to take a look at the first two questions on the exam here, questions 1 and 2. And as we get into question number 1 here, I've just highlighted the idea that there's an object moving to the right, and they're asking you to consider a variety of forces that would do two things simultaneously. One, it would change the direction of motion, and it would decrease the kinetic energy. So we're going to apply a force. You see F is involved in each of these choices, and the force has to do those two things. In the first case, if there's a force upward and the ball is moving to the right, then because there's a right angle here, let's call it vertical component of this force won't be able to change the horizontal component here. So this VI will continue unchanged. And so the kinetic energy, which is 1/2 mv squared, will be the same, but the direction will definitely change. It'll be pushed, say, upward, and this object will move, in some sort of diagonal motion as long as this force is applied. This force here will clearly work against the velocity. You can think of it maybe as friction, and so VI would be changing and the kinetic energy would be decreasing because the velocity would be decreasing. But because it's acting along this same line, the direction of motion won't change. In C, we get sort of force pushing in this direction towards the upper right, and you can imagine that having a component to the right and a component upward. The upward component will change the direction. The rightward component will increase the velocity, which will increase the kinetic energy and clearly not satisfy the condition of the question. And then finally, choice D. This force has a leftward component and an upward component. So again, the upward component would change the direction of the object, and the leftward component will do what the force did in choice B here. It will decrease the energy. So when all is said and done, choice D is our choice for changing the direction and decreasing the kinetic energy. If we take a look at the second question, I've superimposed some lines here to help us think about it. But in the second question, there's a ball on a rope that is suspended and then let go, and it starts to arc out like a pendulum would. Starts to arc out a path here with positions 1, 2, 3, and 4 identified. And the question says, between which adjacent pairs of positions is the change in kinetic energy of the ball the greatest? So is it greatest between 1 and 2, between 2 and 3, or between 3 and 4? So the change in the kinetic energy will be an increase in kinetic energy as the ball moves from at rest to picking up velocity. And if we think in big terms about the potential energy of the ball being greatest here and lowest here, then as it drops and the potential energy drops, the kinetic energy must be increasing. So correspondingly, the bigger the drop, the greater the change in potential energy, and therefore the greatest increase in kinetic energy you'll have. Well, I drew in the lines because it helps you to visualize, I think, where the greatest drop is. And it looks like pretty clearly that the drop between 1 and 2 is larger than the drop between 2 and 3, and certainly larger than the drop between 3 and 4. So the choice here would be between 1 and 2. I think I'll just hold it there, and we'll get into other questions in other videos. But there are the first two questions of our multiple choice exam.